Okay, reading solubility curves. What do we got here? Would it help if I turn the lights out a little bit? Probably so. So a solubility curve is basically just taking a look at a graph and being able to read the graph. I'm going to color this in a little bit. You don't have to do that. It probably might be better if you didn't. You can decide later on. But solubility, basically, you need to know what that. It's the measure of the amount of solute that can be dissolved in 100 grams of solvent. The solute is the one that is dissolved. The solvent is the one that does the dissolving. So those are two terms that you need to know. And then the other terms you need to know would be unsaturated, saturated, and supersaturated. Of course, supersaturated is what we saw in the video. Unsaturated means I can dissolve more. Saturated means I've dissolved as much as I can. And supersaturated would mean that I've dissolved more than I'm supposed to be able to do. And how it relates to the graph is each of these lines represents a different substance. This is potassium nitrate. We have salt, NaCl. So this tells you how much will dissolve, if you look at your axes, in 100 grams of water over here at a certain temperature. And so one of the ways you read these graphs is if your substance or if your number they give you or you're talking about is on the line, it's saturated. If your point is on the line, it's saturated. If your point is below the line, it's unsaturated. So if I used potassium nitrate as an example, any point that falls below the line any point that falls inside the yellow for potassium nitrate would be unsaturated. Anywhere down under here, at different temperatures, that's a unsaturated solution. If the point that I'm discussing, the point that I'm talking about, is above the line, any of these above the line would be called what? Right, so it's supersaturated because it's holding more than it's supposed to. So this would be above the line. So just basically we're looking at a graph and we're trying to get information out of it. We're trying to work with that graph. So let's go through these questions. Remind me as we go along, because I'm going to have to slide this up and down so that you can see it and we can see the questions. If it says how many grams of potassium bromide can be dissolved in 100 grams of 40-degree water? Well, let me use one of these that isn't colored in. It's not shaded in. Oops. So we find potassium bromide on the graph. That's KBr. How much can we dissolve in 100 grams of water, which tells you right here it's 100 grams of water at 40 degrees Celsius. So I find my 40 degrees Celsius. I come up to the line where KBR is at. It's just below the 80 mark. So what would we say? Okay, 78, 79. That's how many grams that I can dissolve at that temperature. That's the maximum amount that 100 grams of water will hold. Okay. Number two, what mass of potassium nitrate can be dissolved in 200 grams? You notice in this case they made it bold-faced to try to highlight that. This is how much I can dissolve in 100 grams of water. So we find our 30 degrees right here. I come up to the line, potassium nitrate, kind of where all these intersect here. I go across. How many grams would you say that is again? Maybe 38? So I can dissolve 38 grams in 100 grams of water. So in 200 grams, I'm going to multiply it times 2. So it would hold, oops, you're right. That's what happens when you do math in your head. 76 grams. 76 grams. Questions so far? Number 3, a solution contains 20 grams of yttrium sulfate in 100 grams of water at 35 degrees Celsius. Is this saturated, unsaturated, or supersaturated? So we're going to compare it on the graph to the line. So this is the line that we're discussing, the one that's curving down. We go to 35 degrees. We intersect the line. But actually we just want to find what, 20 grams? 20 grams, 35 degrees. Actually it's right on the line. So if it's on the line, what is it? Okay, so it's saturated. Okay. And it's saturated because it falls on the line of solubility. If my point was above the line, it would be supersaturated. If my point was below the line, it would be unsaturated. Number 5, a solution contains 20 grams of NaCl, sodium chloride, in 100 grams of water at 40 degrees Celsius. How much more could be added? So my NaCl is the one that's pretty flat here. We have 40 degrees. How much can we dissolve? We would go up to the line, intersect that, and we're at about 38 again, right? That's how much it can hold. It could hold 38 degrees, but we only have 20 grams dissolved. So the difference between those two is how much I can add to it. So the difference would be 18 grams more. That's how much more we could dissolve until it reached the saturation point. Number 6, at what temperature are the solubilities of potassium bromide and potassium nitrate equal? We just look and see where do the two lines intersect. So find potassium nitrate, that's this steep one, and potassium bromide, they intersect right here. So if they intersect there, at what temperature? So we drop down, we'd say somewhere around, okay, good, 55 degrees. It's just applying graphing to chemistry. You all have done plenty of graphs in your long years of education. In general, as the temperature of the solvent increases, the mass of a solid solute will increase. Which of these compounds in the graph is an exception to the rule? So they're just basically saying, if you look at all these, the hotter it gets, they all tend to dissolve more, right? There's one exception to that. Which one is that? Yeah, this one does slightly or it flattens out, but the one that's really exception to the rule is this one that curves down, right? So, oops. So that one actually decreases. The hotter it is, the less I can dissolve, which is really unusual. It's not usually the way it is. How does the solubility graph of gases dissolved in water compare to the curves in the graph? Okay. Well, basically, gases are the opposite of solids. So the hotter it is, the less you can dissolve. Okay. So we'll say the hotter the solution, the less can be dissolved. So in the summertime, when the water gets hot in a pond or a lake, there's not as much oxygen dissolved in the water for the fish as it is when it's cooler. In fact, some small ponds, sometimes if it gets real hot for a long period of time, you might have a little bit of fish die off if you have a whole bunch because there's just not enough oxygen in the water. Okay? Your soda that you drink, it'll be more bubbly if it's cold. It'll stay longer. If you heat up a soda, by the time you get done heating it up, there won't be any more carbon dioxide left in it. It'll be all dissolved, or it will all come out of this solution. Good job. Okay, lastly, a solution of potassium nitrate contains 130 grams and 100 grams of 70-degree water. Is this one unsaturated, saturated, or supersaturated? So again, we're dealing with potassium nitrate at 70 degrees. So this is my line for potassium nitrate. This is my 70 degrees. I have 130 grams dissolved in here, which puts my point right up there. So is that above the line, below the line, or on the line? It's above the line. So that means it's supersaturated. And how do we do that? We would dissolve 130 grams in 100 grams of water. And heat above 70 degrees till all of it dissolves. I would just measure out how many grams I have. I would get it up above 70 degrees, give it a minute to dissolve, and then you really want to let it cool slowly to get super saturated. Not all solutions, not all chemicals can be like that. It's very tough. Sodium acetate, like the video I showed you, just happens to be one that's a little bit easier to manipulate. In fact, they use, if you ever had the little hand warmers that are, you can reheat, reuse them, they usually have sodium acetate in them. The ones that you can use in the wintertime, say you go hunting and it's cold outside, There's a little clicker in there that once you click that, that helps that crystal grow. When that crystal grows, it gets hot, it gets warm, and it's reusable. Because then when you're done, you can take it, throw it in a boiling hot water bath, where you dissolve it all again. It's in a little plastic container. So, okay, so your job now is to turn it over on the back. You have way too much time. You got all kinds of time to get that done. So do a good job.